Hello everyone, and welcome to another math tutorial. This video is a follow-up to the 1.4 video on graphing linear inequalities in two variables. This is another one of my extra practice videos. So if you're here watching this, I assume the first video might have been a little bit confusing and you'd like a little more practice. I suggest a good idea would be to maybe pause the video at the start of each question and try to work it out on your own, and then you can watch the video or fast forward to the solution of each problem to check your answers. Alright, this first problem we are graphing y is greater than negative 2/5 x minus 4. I'm going to start by plotting the points of the boundary line, which are going to begin with a y-intercept of negative 4. And then have a slope of negative 2/5. Now I can't go down 2, it's going to go off my graph, so I'm just going to go up 2 and to the left 5. And from there I'll go ahead and connect my points. I am going to need a dashed line because there is no equal to on this inequality. Okay, next we need to shade either above or below our line. Now we want the area of the line that is greater than the line. So we want to shade greater than implying above the line. So everything above is going to get shaded. And that's all there is to this problem. Alright, this next problem asks us to find the solution region to the system. So here we have a system. We've got two linear inequalities. We're going to graph both of them with their appropriate shading. And then we're going to look for an area of overlapping shading. So the first one is just y is less than or equal to 6. That's going to be a horizontal line at 6 on the y-axis. And because there's an equal to, it needs to be a solid line. Alright, because it says less than, we want everything that is beneath the line. So I'm going to do my shading below the line, but I'm not going to shade just yet until I have figured out where the other line is and where it is going to shade. Now the other inequality, y is greater than negative 2x minus 5. It's going to start at negative 5 on the y-axis. Has a slope of negative 2, which I can think of as negative 2 over 1. So we're going to go down 2 and to the right 1 for our points. We could also go up 2 and to the left 1 to be on the same line. So plot as many points as you need to make sure this line is going to be straight, and then we'll go ahead and sketch the line. Notice that there's no equal to, so this is going to be a dashed line along these points. Okay, because we want greater than this line, greater than is going to imply the above side of this line. And the above side of this line, if we're looking at here, we've got above and below. I'm going to want everything that's up here in this area. So we're shading this direction. And now we can kind of see where the overlap is going to be. If I want everything below this line and above this line, that's going to be everything inside of this area here. So I'm just going to go ahead and shade that. And that's my solution region to this system. The final problem in this video asks us to find the area of the figure formed by the solution region. So we have enough lines over here that we're going to be able to create a region that is bounded on all sides. And because it's bounded, it's going to create a polygon. We can find the area of that polygon. So that's the idea. So let's just go ahead and begin by drawing all three lines. Notice that there's equal to on all of them, so they're all going to be solid lines. This first one, x is greater than or equal to negative 3, is going to cross the x-axis at negative 3, and it's going to be a solid line. Now, greater than negative 3, there is no above and below this line because it's not horizontal or slanted. So above and below is synonymous to the right or to the left of this line, and greater than is numbers that are out to the right. So we're going to need to shade everything right side of that line. The next line, negative 2/3 x plus 2, is going to start at 2. It's going to have a slope of negative 2/3, so down 2 and to the right 3. So again, fill in as many points as you'd like and get it going both directions. Once you're happy with that, go ahead and connect those points with a line. Okay, and we want the less than side of this line. So we want the beneath side of this line. So we want everything below going that direction. So right now we're to the right of the vertical line and we're underneath this slanted line. So right now we're inside here. Let's see what this last line brings us. We want y is greater than or equal to -2. So we're going to cross the y-axis at -2. Y equals is a horizontal line. So right here at -2, we want it to go just straight across horizontal. And this inequality is greater than is going to imply or mean above this line. So we want everything now that is inside this triangular region that's been formed. Now, because we have a triangle, and more specifically we have a right triangle, the area of a right triangle is half times its base times its height. The right angle being right here makes the base and the height the legs of the triangle. So there's the base, there's the height. We can just count them. The height is 1, 2, 3, 4, 5, 6 units. The base is going to be 3, 6, 9 units. So our area is going to be 1/2 times 9 times 6. 9 times 6 is 54, and half of that is 27. So our area is 27 units squared. Okay, that completes this extra practice tutorial on graphing linear inequalities in two variables. If you have any further questions, please drop them in the comments below. If you liked this video or you found it helpful, please give it a thumbs up, and I'll see you in the next one.